Victories of the day, April 4th.
1. 1883, the completion of the first wrought iron railway bridge. On April 4, 1883, the first major wrought iron bridge in its region was finalized, a milestone in metallic load-bearing analysis. Prior to the 1880s, bridge building relied on brittle cast iron, which often failed under the dynamic tension and vibration of heavy steam locomotives. The system utilized riveted wrought iron trusses, which offered high tensile strength and could flex under load without structural snapping. This shifted civil engineering toward elastic design, proving that high-speed rail networks required materials that could absorb and distribute kinetic energy. This achievement pioneered the truss logic used in modern steel bridges, allowing for longer spans and heavier freight capacities globally. 2. 1953, the publication of Information Theory Foundations. In April 1953, significant expansions on the Shannon-Hartley theorem were presented, a milestone in channel capacity mathematics. Before this, there was no mathematical way to calculate exactly how much data could be sent through a noisy wire without losing the message. The system utilized logarithmic probability functions to define entropy as a measure of information uncertainty within a communication system. This shifted signal processing from analog approximation to digital quantization, proving that error-free communication is possible even in a noisy environment. This achievement is the reason we have 5G, Wi-Fi, and deep space communications. It provided the mathematical limit for how much data can fit into a radio frequency. 3. 1933, the crash of the USS Akron. On April 4, 1933, the USS Akron, a helium-filled rigid airship, crashed during a storm, a milestone in extreme weather structural analysis. Prior to this, the Navy believed massive airships were superior for maritime surveillance. The effects of vertical wind shear on long airframes were poorly understood. The system utilized internal structural girders made of duralumin, which failed when the ship was forced tail-first into the ocean by a violent downdraft. This shifted aeronautics toward aerodynamic stress modeling, proving that the size of an airframe created a leverage effect that could exceed the material strength. This achievement ended the era of the rigid airship as a primary military tool, shifting global investment toward fixed-wing aircraft and pressurized cabins. 4. 1949, the signing of the North Atlantic Treaty. On April 4, 1949, NATO was formed, a milestone in interoperable technical engineering. Prior to 1949, Allied nations used different ammunition calibers, radio frequencies, and fuel types, making large-scale coordination slow and error-prone. The system utilized STANAGs, standardization agreements, which mandated that all member nations use identical physical and digital interfaces for their equipment. This shifted defense logistics toward universal compatibility, proving that a multinational force is only as strong as its shared technical protocols. This achievement created the world's first transnational technical network, providing the framework for modern plug-and-play logistics used in global trade. 5. 1968, the first successful partial heart transplants. On April 4, 1968, surgical teams finalized the first successful series of heart valve replacements using synthetic and biological grafts. Before 1968, mechanical failures in the heart's fluid logic, valvular disease, could not be repaired with precision, often leading to terminal heart failure. The system utilized Starr-Edwards ball valves, which used a silicone ball in a cage to regulate blood flow, mimicking the natural check valve function of the heart. This shifted cardiology toward prosthetic integration, proving that the human body could accept engineered mechanical parts to maintain life-critical circulation. This achievement established the field of biomaterials, leading to the modern development of 3D printed tissues and titanium heart implants. 6. 1975, the founding of Microsoft. On April 4, 1975, Bill Gates and Paul Allen founded Microsoft, a milestone in the decoupling of software from hardware. Prior to 1975, software was usually bundled as a free extra with a specific computer. There was no independent market for high-level programming languages for home users. The system utilized an Altair Basic Interpreter, which allowed users to program the MIT's Altair 8800 using standard mathematical commands rather than binary code. This shifted computation toward platform-agnostic software, proving that the logic of a computer was more valuable than the plastic it was built from. This achievement founded the global software industry, establishing the operating system as the primary interface between human intelligence and machine processing. 7. 1983, the launch of the Space Shuttle Challenger. On April 4, 1983, the Space Shuttle Challenger launched for the first time, a milestone in reusable heavy lift capacity. Before the STS program, space travel was a disposable endeavor. Every launch required an entirely new rocket, making the cost per kilogram astronomically high. The system utilized the Space Shuttle main engines, SSME, the most sophisticated liquid-fueled engines ever built, designed to be recovered and fired again. This shifted aerospace engineering toward cycle-based economics, proving that orbit could be reached using a vehicle that behaved more like an airplane than a missile. This achievement deployed the first TDRS satellite, establishing the high-bandwidth space network that allows NASA to maintain 24/7 communication with astronauts today. 8. Scientist of the Day, Claude Shannon. Claude Shannon is often called the father of the information age. His work transformed communication from a vague engineering problem into a rigorous branch of mathematics. Shannon realized that information could be treated as a quantifiable physical quantity, much like energy or mass. He introduced the bit, binary digit, as the fundamental unit of information. He borrowed the concept of entropy from thermodynamics to describe the uncertainty or randomness in a message. Before Shannon, engineers believed that if a communication channel, like a copper wire or radio wave, had too much static, noise, the message would inevitably be corrupted. Shannon proved the noisy channel coding theorem: as long as the data rate is below the channel capacity, you can use mathematical codes to achieve nearly error-free transmission. Every time you use Wi-Fi, 5G, or stream a video, Shannon's equations are working in the background. They dictate exactly how much data can be squeezed into a frequency and how to correct errors caused by interference. His 1948 and 1953 papers shifted the world from analog, continuous signals prone to degradation, to digital, discrete bits that can be perfectly reconstructed.
Victories of the Day, April 4th.